Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper Vault, where we are solving past paper questions of IGCSE Physics 0625. Currently, we are solving the papers of October-November session 2025, and today we are doing the variant P43. So let's begin, but before we start, kindly like and subscribe the channel, and if you find anything helpful, kindly remember me in your prayers. Thank you. Question number 1, part A. A hard ball is dropped vertically downwards. Figure 1.1 shows the speed time graph for the ball from when it is dropped until it hits the ground. Air resistance is ignored. Okay. So describe the motion of the ball in figure 1.1. Since it's a straight line graph, so we will describe the motion to be constant acceleration. ठीक है जी. It is constantly accelerating. Since you know that the gradient of the speed time graph represents acceleration, and since it's a straight line one, so it is a constant acceleration. Show that the distance traveled by the ball is 1.8 meters. Now we all know that the distance under the graph is given by the distance. Okay? So what we are going to do is we are going to draw a line over here, and we can see that over here we've got a triangle. Okay, so we will find the area of the triangle, and then we will get to know that the distance traveled is what was it, 1.8 or not. So area of triangle is equal to half base into height. That is half. The base is 0.6 and the height over here is 5.8. So we are going to write that down and then calculate it, and we get the answer to be 1.74, which can be rounded off to 1.8 meters. So yeah, it's the same. Okay, the mass of the ball is 0.54 kgs. Calculate the gravitational potential energy stored in the ball immediately before it is dropped. So gravitational potential energy's formula is mg and h. Since we know the mass to be 0.54 and the value of g is 9.8 or 9.81, and the height we've just seen was 1.8, we've just taken it out. So when we multiply all of this together, so we get an answer of 9.52 joules. Okay. So moving forward, fourth part, determine the kinetic energy of the ball when it has fallen halfway to the ground. Okay. So we've just taken out gravitational potential energy to be 9.52 joules. And we know that according to the law of conservation of energy, energy can neither be created nor destroyed. One form of energy is converted into another form. So over here, gravitational potential energy will be converted into kinetic energy. So the total gravitational potential energy is 9.52. So when it reaches the ground, so the total kinetic energy, ideally speaking, would be 9.52 joules, okay? But they are asking about halfway. So this is half. So what we are going to do is we are going to multiply it with half or divide by 2 or multiply it with 0.5. So we will get an answer of 4.75, which can be rounded off to 4.8 joules. Okay. Pretty straightforward. Okay, B. The same ball is dropped from an aeroplane. Air resistance now this time acts on the ball. Explain how the vertical motion of the ball changes when it is dropped to just before it hits the ground. Okay, so for this to happen, if we have a plane and the ball has been dropped from it, so firstly what is going to happen is that this ball is going to accelerate because the only force that is acting on it is in the downward direction, that is the weight of the ball. As it accelerates, so another force, that is the frictional force, and opposite to the direction of the motion, that is air resistance, starts to act on the ball. Okay. As a frictional force has started to act, so it accelerates now less. Okay. The acceleration becomes less. Okay. And then there comes a time when the air resistance and the weight of the ball both balance each other out, and the ball reaches terminal velocity where the resultant force on the ball is zero. So from now on, so the ball is going to fall with a zero acceleration. ठीक है, so when the acceleration is zero, so until it reaches the ground, so the speed is going to be constant. ठीक है, so this is the principle of a free falling object when air resistance acts on it. So this is what we are going to write over here. Let me clear the space and write. I've written down what I explained earlier, and we have to give reference to the forces. So we are going to write that when the ball starts to fall, it accelerates as the only force acting on it is the weight in the downward direction. After a while, in opposing force, air resistance starts to act on the ball and its acceleration decreases. Then comes a time when weight and air resistance balance each other and resultant force acting on the ball is zero. So now it falls to the ground with constant speed and zero velocity. And one more thing, that if you need more space for your answer, you can go beneath one line, but the best thing to do is that notify over here that you've written the answer on the blank pages that are provided to you, so that you can write your answer full length and whatever the amount in which you like to write that answer, and don't use the space below and don't go below these lines. Okay, always use the blank spaces to complete your answer. Okay, moving on to part C. A softball is dropped by a student so that it bounces on the ground. Figure 1.2 shows the height time graph of the ball. The height is measured from the ground. The ball bounces 4 times. Explain why the change in height of the ball between B and C is less than the change in the height between A and B. Now, since we know that according to the law of conservation of energy, energy can neither be created nor destroyed, it just converts into another form. So over here it had fallen from some height, so obviously it had gravitational potential energy, and since it was moving, the gravitational potential energy stored was being converted into kinetic energy, and then when it bounced over here, some of it was converted into elastic energy as well, and then it again went up and gravitational potential energy that would have converted into kinetic energy, and so on. So the change in the height is due to the fact that some of the energy is transferred to thermal energy store. That is also one of the explanations of the ground when the ball hits the ground. And you can also write the explanation I just gave you. That when ball hits the ground, some of the energy is converted into elastic energy and some is converted to thermal energy as well. So whatever suits you and whatever you like, both would be correct. Question number 2. A cricket ball is traveling at a speed of 25 meters per second horizontally through the air. The mass of the ball is 0.14 kgs. The player catches the ball and ball comes to rest. Calculate the change in momentum of the ball during the catch. Okay, change in momentum. Change in momentum is calculated by the formula delta P is equal to m final velocity minus m initial velocity. So over here we see that the initial velocity was 25 meters per second, and as the ball came to rest, so the final velocity would be 0. So we can also write this as m vf minus vi. You can use u and a instead of f and I. I find it helpful and it's not wrong, so I use these, but you can use whatever you want. Okay. So the mass is 0.14 and the final velocity is 0 and the initial was 25. So when we multiply this all together, we get an answer of minus 3.5 kg meter per second. Okay. So moving on to part B, the player's hands are in contact with the moving ball for 9.7 milliseconds. Calculate the horizontal force exerted by her hands to bring the ball to rest. So when we are talking about momentum, we know that force can also be expressed as change of momentum over time. So since we have a change of momentum over here, we've just calculated that, so we will use this formula, minus 3.5, and this time is in milliseconds, so we have to convert it into seconds. So 9.7 into 10 raised to the power minus 3 seconds. So we are going to write that down over here, and we will get an answer of 360 newtons. Right? Okay, moving on to question number 3, part A. Figure 3.1 shows a Sankey diagram for the power transfer in a coal-fired power station. Okay. Show the useful power output from the power station is approximately 1100 megawatts. Okay. According to the diagram, power input from fill was 3400 megawatts. So until it reached here, there are some diversions that it took. Some of this power input was wasted in power station due to thermal energy transfer, and that amount was 2200 megawatts. Some of the power is used in power stations, that is 40 megawatts, and power used in transmission was 25 megawatts. So all the power that does not reach over here, this useful power output point, is considered to be wasted energy. Okay. So now what we have over here is that our total input was 3400 megawatts. So 2200 megawatts, plus 40 megawatts plus 25 megawatts has to be subtracted in order to see that what is the useful power output, and is it equal to 1100 megawatts. Okay. So when we subtract all of this from 3400, we get an answer of 1135 megawatts. So it is almost equal to 1140 megawatts. Okay, if it is rounded off, so it is almost similar to 1100. Part 2, calculate the efficiency of the power station. So efficiency can be calculated by the formula useful power output by total power input. So our useful power output was we can say 1100 megawatts, since it's this amount is given in the question, so we can use that. And the total power input was 3400 megawatts, so the efficiency is going to come out to be 0.32. Okay, and if you want a percentage efficiency, then you can multiply with 100. Okay, so that's going to be 32%, I think. Okay, B. Describe how useful energy may be obtained from geothermal resources. Now, geothermal resources are the ones in which you use the hot rocks that are energy from the hot rocks that are present inside the surface of the earth. So what we do is that we pour water over them, and over these hot rocks, and that water is converted into steam, and that steam is actually used to run turbines to produce electricity, right? So I'm going to write this process. So we can write water is pumped into ground and it gets heated by hot rocks, and then the steam can be used to turn turbines to produce electricity. Write this down and you are going to get your 2 marks. Question number 4. A rectangular glass tank contains a 3.0 meter cube of liquid. The mass of the liquid is 2800 kgs. Calculate the density of the liquid. Okay. Density of the liquid or density of anything can be calculated by density is equal to mass over volume. Since we have a mass and we have a volume, so we are just going to put in our values over here and we will get an answer of 133.3, which can be rounded off to 930 kg per meter cube, right? Okay. A metal block is placed in the tank and it sinks to the bottom. The top surface of the block is 1.1 meter below the surface of the liquid. Okay. Figure 4.1 shows the block on the bottom of the tank. Okay. Calculate the force exerted by the liquid on the top of the block. Since we are talking about pressure and density and volume, so the force can be calculated by the formula pressure is equal to force over area. Okay. Now over here we can find the area very easily with these dimensions that have been provided to us, but we don't have the pressure. But pressure in this case can be found by our formula rho gh. We've just found out the density, right? So that was 930 kg per meter cube, and we know the value of g as 9.1 and height they've given us to be 1.1 meters. So we are going to put in these values and we will get an answer of 0.4, and this can be rounded off to 10,000 pascals. Okay, so now once we have our pressure, we can easily put in the values and find the force. Okay, and then we have these two values over here, 0.30 and 0.45. We can also first calculate them, the area 0.30 into 0.45, 135, which can be rounded off to 0.14 meter square. And when we, let me write it down over here, when we multiply these two, we 1400 newtons. Okay, I basically did all this over here because the answer was 1400 newtons. So if we round off our pressure and if we round off our area, then we get the correct figures, that is 1400 newtons, right? You can do it whatever you feel easy with. You can convert the answer in the end as well. Okay, part B, figure 4.2 shows part of a steel railway track. There are small gaps between sections of the rail. Yes. State why gaps are needed between the sections of the rail. Explain your answer in terms of particles. These gaps are left because of thermal expansion. The metals tend to expand, the solids tend to expand a little when they are heated. So if they have space in between them, so this, when they expand, so they can just take over this space. Otherwise, if this space is not left between them, so they will start to overlap each other and there would be accidents. Okay, so our statement is going to be that they are needed due to thermal expansion. And for explanation, we will, on a hot day, the temperature increases, so the particles have more kinetic energy and they vibrate faster, taking up more space. So the separation between the particle increases, and that is why it expands. And since they asked us to write our answer in terms of particles, so we've mentioned the particles, they're changing kinetic energy, they're taking up more space over here. Okay. Part C, figure 4.3 shows saucepan of boiling water on the heating ring of an electric cooker. Yeah, the handle is made from plastic. Explain why this material is suitable. Now we know that plastic is an insulator, so it will transfer heat energy slower than a conductor does. All right, and since it is not a metal, it does not have free electrons that help with the movement of heat and obviously in some cases electricity as well. So if we need to heat something and pick the pan, our hand is not going to burn. Okay, that is why the handle is made from plastic. So we will write that plastic is an insulator of heat, so it will not get hot, too hot actually. We should write over here, and burn our hand while using the handle. Okay, so moving on to question number 5, part A, and the first part of A. Electromagnetic waves have many uses. On figure 1.1, draw one line from each use to region of the electromagnetic spectrum it uses. Okay. Now security markings use ultraviolet. Bluetooth uses radio waves. Optical fibers use infrared, and detection of cancer is done by gamma rays. Yeah. Okay, part 2, state one advantage of using microwaves compared with radio waves to transmit mobile phone signals. The advantage is actually that microwaves have a much higher frequency than radio waves. So we can just, microwaves can pass through the atmosphere. Okay, so we can write any one of those. So we can write microwaves can pass through the atmosphere since they have more frequency and lesser wavelength. Part B, describe one difference between transverse waves and longitudinal waves. So transverse waves are waves in which the particles vibrate perpendicular to the motion of the waves, and longitudinal waves are the waves in which the particles vibrate parallel to the propagation of the wave. And we can also write, since they are of 2 marks, so we have to write 2 differences each. We can also write a difference that transverse waves don't need a medium and longitudinal waves need a medium. So we'll just write them. So I've written down both the reasons, the vibration of the particles and the requirement or no requirement of the medium, right? So moving on, part C. Figure 5.1 shows a simplified diagram of seismic P waves traveling through the earth. The path of the waves are curved. Seismic waves are produced by rock movements in earthquakes. Okay. So state the type of the wave, that P waves can be modeled as. So P waves actually are longitudinal waves. These P waves are come under longitudinal waves, and those S seismic waves come under transverse waves. Okay. Part 2, at point X, the P wave travels from solid mantle to the liquid core. There is a sudden change in the direction of the path of the wave. Explain the change in the direction of the P wave at point X. Now, as it has traveled from solid to liquid core, so this would be more dense and this would be less dense. So there is going to be a change in the speed of the wave. So change in speed and moving from more dense to a less dense medium gives rise to refraction. So we can write that due to the difference in the densities of the materials, the wave is going to experience a change in speed, giving rise to refraction. Okay. So this part is done. Part D. The Earth's surface absorbs incoming radiation from the sun and also emits thermal radiation from its surface. Over the past 50 years, scientists estimate that the average temperature of Earth's surface has increased by approximately 0.75 degrees C. Explain what is causing this average rise. So this average rise is caused by greenhouse gases, since they trap more carbon dioxide and methane, and these gases, the greenhouse gases, actually trap more air than it is required to keep our planet heated and at a good temperature. So because of that, there is this average rise in temperature. So we are going to write that, right, this is caused by greenhouse gases that prevent radiation to escape back into space, making the temperature of the Earth's surface to rise. This is basically the principle of global warming. Okay, moving on. Question number 6, part A, figure 6.1 shows a circuit which includes an LDR, light dependent resistor. The LDR is in a brightly lit room. The voltmeter reads 1.8 volts. So over here, this resistor is receiving 1.8 volts, right? So calculate the current in the 400 ohm resistor. Okay, let's first discuss what an LDR is. Or light dependent resistor is. So LDR basically a light dependent resistor works in such a manner that more the light, since it's dependent on the light, more. Okay, let's first discuss what LDR is. So LDR is a light dependent resistor, so it depends on the light. So more brightness of light and less will be its resistance, and vice versa. Okay, so once we've established this, let's calculate the current in the 4 ohm resistor. Actually, 5 volt is being supplied to both the resistors. So if one of the resistors is getting 1.8 volts, and as this is a series circuit, and in series, the total voltage is V1 plus V2 plus V3 and so on. So whatever voltage this resistor is receiving, so this is going to be receiving 5 minus this one. Okay, so we are going to calculate our current with the formula V is equal to IR. So V for this resistor is going to be 5 minus 1.8 is equal to I, and R is 400 ohms. So this is going to give us a current of 0.008 amperes. Okay. Okay, part 2 asks us the light level in the room changes from bright to dark. State and explain the effect on the voltmeter reading. Okay, now I just told you that when the brightness is high, the resistance is low. Okay? And now when the brightness is low, the resistance is going to be high. And if the resistance is higher, the voltmeter reading is going to go higher as well. Okay, so let's write it down over here. Okay, our statement would be that when brightness is reduced, the resistance of LDR will increase. And as we know that the resistance and voltage are directly proportional to each other, so explanation would be that the LDR has a greater share of total voltage, right? So moving forward, part B. Figure 6.2 shows 2 light-emitting diodes connected in parallel in a circuit. R is a red LED and G is a green LED. The voltmeter across the LEDs shows a potential difference of 2 volts. Okay. So figure 6.3 shows a current PD graph for the LEDs. Use figure 6.3 to determine the current in the ammeter. Okay. Okay. We have the voltage to be 2 volts and we have this graph between current and PD. So what we are going to do is we are going to draw a line over here and then find the corresponding values for red and green LEDs in terms of current. So for the green one, the value for current would be 12, and for the red one, the value of current would be 44. All right. So what we are going to do is that if we want to determine the current in the ammeter, we are just going to add these two currents That is going to give us 56 milliamperes. So we are going to write this, already straightforward. Then part 2 states that the connections to the power supply are reversed. State the reading on the ammeter. So these are diodes, and we know that they allow the movement of the current in one direction only. So if the connection is reversed, so there won't be the current would be zero. They will not let the current to flow through. So we can just write that the current is going to be zero. Since these are diodes, and if connection is reversed, they will not let the current to flow through. Moving forward. Okay, question number 7. Figure 7.1 shows a simple AC generator. Okay, explain the function of slip rings and brushes. Okay, one of the function of slip ring and brushes may be that they prevent the wires to the lamp from tangling, but what we should write is that basically slip rings allow AC current to flow between the coil and the external circuit, and carbon brushes provide good electrical connection between coil and the external circuit. So that will cater to both. And yeah, so slip rings allow AC current to flow between the coil and external circuit, and carbon brushes provide good external electrical connection between coil and the external circuit. Describe how an alternating current is generated in the lamp. Okay, we have this rectangular coil that rotates in uniform magnetic field. The coil is connected to the external circuit through slip rings and brushes. An EMF is induced in the coil as it cuts the magnetic field, and as due to this changing EMF, an alternating current is also produced due to the rotation of the coil, and this continues to do so until the coil keeps on rotating in the same direction. Okay, so we are going to write this down. Okay, a rectangular coil rotates in a uniform magnetic field. The coil is connected to the external circuit using slip ring and brushes. An EMF is induced in the coil as it cuts the magnetic field. As a result of this alternating EMF, an alternate current is also produced as the coil rotates, and it continues to happen until the coil keeps rotating in the same direction. So moving forward, state 2 possible changes that can cause larger maximum current in the lamp. Increasing the number of coils, using a stronger magnet, and it can also be increased if you increase the speed of rotations. So third can be increasing of rotation is increased. You can write any two of these. All right. Part B. Figure 7.2 is a graph that shows how EMF varies with time for the coil. Determine how many revolutions the coil has made from time 0 to E. Okay, so it starts from 0, reaches its maximum point, then goes 0 again, then reaches its maximum point, and we know that one wavelength is going to be from this to this point, and then there is another one. So this is one wavelength, and this is another wavelength, and this is half wavelength. So number of revolutions would be 2.5 revolutions. One revolution means one wavelength, so they are almost like 2.5 wavelengths, so 2.5 revolutions. Okay. Moving forward, part 3, figure 7.3 shows the end view of the position of the plane of the coil at time t is equal to 0. The coil is rotating anti-clockwise. On figure 7.4, draw 4 lines to match the coil position to the times A, B, C, and D. The coil is viewed from the front. Okay, each coil position may be used once, more than once, or not at all. Okay, so if we now look at the graph, we can see that at position A, the EMF is going to be maximum, so the coil is going to be horizontal like this. At position B, the EMF produced would be 0. So that means the coil would be vertical. Coil will be vertical in position, and at point C it is 0 again. So point C maybe it is going to be vertical, and at point D, if we draw this line, it is going to be maximum. So it means that it is going to be horizontal again. So now if we look at the positions of the coils, at point A where the EMF was maximum, we need something that shows a horizontal position. So this shows the horizontal position. At B and C, the EMF was 0. So I just told you that the coil had to be vertical. So this position shows the vertical coil. So C और इसका इकट्ठा होगा in D पे, again it is going to be maximum, so the coil is going to be horizontal. So D का भी coil position would be the same as that of A. Seems little difficult, but it's actually not, if you know your concepts. Okay, question number 8, part A. Alpha particles are directed at very thin sheet of coiled foil. The following observations provide evidence for the nuclear model of atom. State what conclusion can be made about the model of the atom from these observations. Okay, observation. Most of the particles pass straight through the foil. So explanation for that would be that the atom is mostly empty space, or the nucleus is tiny. You can write any one of these. I've written down the conclusion that I just told you. Part 2, observation is a few particles bounce back or are deflected through large angles. Deflection and bouncing back would be done because positive charge is concentrated in the nucleus. Okay, so alpha particles are also positively charged, so they are repelling each other. Okay, so we can write nucleus positively charged, so it repels positively charged alpha particles. Figure 8.1 shows 3 beams of ionizing radiations, alpha, beta, and gamma, passing between 2 parallel plates. The plates are charged and there is a uniform electric field between them. State and explain which path P, Q, and R shows a beam of alpha particles. Okay. Q basically is gamma rays, because gamma rays are the ones that pass undeflected through electric as well as magnetic field. Okay, so R are going to be beta particles, since they are very light and they are fast moving, so they get deflected very easily. And P is going to be our alpha particles, because they have a greater mass, so they deflect less than the beta particles. Okay, so path of alpha particles would be B, and explanation would be that alpha particles moving forward. State and explain the direction of electric field between the plates. Okay. Now, because of what we've just established, that alpha particles are being deflected in this direction. So this alpha particles are positively charged particles, so this must be negatively charged plate, and beta particles are negatively charged particles and they are deflected towards this plate, so this would be positively charged. Okay, so the electric field would be, electric field is always from the positive to the negative end, so it would be upwards. Okay, so let's write it down. So direction would be upwards, and explanation would be alpha particles are positively charged, so they will be attracted to negatively charged plate. Moving to part C, curium 242 is a radioactive isotope. It emits alpha particle. It has a half-life of 160 days. After 480 days, the mass of curium-242 in a sample is 2.4 into 10 raised to the power minus 3 grams. Calculate the initial mass of curium-242 in this sample. So what we first need to do is that we need to establish how many half-lives have actually passed. Okay. So what are we going to do is that we are going to divide 480 with 160. So this is going to give us an answer of 3. So there are 3 half-lives that have passed. Okay. So they just told you that after 480 days, the sample has 2.4 into 10 raised to the power minus 3 grams of curium left. So initial mass kitna tha? Okay, to understand the scenario, let's do reverse engineering. You know that when we have to find out how much sample is left and we have the initial one, for example, we have this over here, so 1 half-life, it has to be divided by 2 and it is going to be halved. And then another half-life passes divided by 2 and it is going to be halved. And then another half-life passes and we reach this much sample. Okay, 3 half-lives have passed. So if we want to go backward, what we are going to do is we've been dividing by 2, so we need to multiply by 2. So what was there in the end multiplied by 2 at the end of second half-life would be 0.0048. And then after first half-life, if we multiply this with 2, we will get 0.0096. And obviously, initially, before anything happened, if we multiply this value with 2, we will get an answer of 0.0192 grams over here. Okay? So it went from this to this, so we can also go from here to here. Okay? It is just for the understanding purpose. Secondly, we have this method that you multiply the mass with 3 half-lives. Okay? So mass is going to be 2.4 into 10 raised to the power minus 3 multiplied by 8 is going to give you 0.0192, which is the same, and you can just write 1 to 1.9 into 10 raised to the power minus 2 grams as well. So you can follow whichever method suits you. No issues with that. This, I think, is a better way to explain that what has been done. But it's up to you guys. Okay, question number 9. Cosmic microwave background radiation, CMBR, can be observed in every direction in space around us. State when CMBR was produced. CMBR were produced when when universe was formed. Obviously. Part 2, state and explain how the wavelength of this radiation has changed since it was formed. It has increased since the universe is also expanding, so the wavelength of this radiation has increased. Yeah, so moving on. Table 9.1 shows data about planets in our solar system. The orbit of Venus is approximately circular. Calculate the average orbital speed v of Venus. Give your answers in kilometers per hour. Okay. So the orbital speed can easily be found by S is equal to d over t, and the d being 2 pi r, because they've told us that the orbit of the Venus is circular. So 2 pi r over t. So what do we have over here? 2 pi, and the radius for Venus is 108 into 10 raised to the power 6. Please don't forget these things over here, okay? It's not just 108 into 10 raised to the power 6, and the time for the orbit is 0.6 Earth years. So this has to be converted into hours, since we have to give the answer in kilometer per hours. So one year में there are 365 days, and in one day there are 24 hours. So we are going to divide these two together to get our hours in a year. So there are 8,760 hours multiplied by 0.62, since this has to be converted. So this gives us an answer of 124,941.8, and this can also be written as 1.2 into 10 raised to the power 5 kilometer per hour have already been written. State how the average surface temperature of the planet changes as its distance from the sun increases. So you can see in the table that from Venus to Saturn it's decreasing. So we can just write down it decreases. Okay. So moving forward to question number 10. Number 10, part A, sketch a diagram to show the orbital path of a comet around the sun. Mark the position of the sun in your diagram using S. Okay, now we know that the orbital path of a comet around the sun is elliptical. ठीक है जी, so this is going to be elliptical, and you can mark S anywhere, over here or over here. So with S, so the sun is going to be here. Acha, draw a cross on your diagram to show where the comet is traveling with the slowest speed. So the comet is will be traveling at the slowest speed when its distance from the sun is the greatest. So almost point, this would be L, and as the distance from the sun decreases, then the orbital speed then the speed of the comet increases, and over here the gravitational potential energy would be the greatest, and kinetic energy would be the least, and somewhere close to this gravitational potential energy would be less, and kinetic energy would be more. ठीक है, as we know the principle. Part C, explain why the speed of the comet changes as it travels around the orbit. Yes, so the speed of the comet changes because when the comet is away from sun, it has more gravitational potential energy and less kinetic energy. As it moves closer to the sun, the gravitational potential energy store converts into kinetic energy store. So as comet has more kinetic energy, so obviously it has more speed. So let me write that down. So since they've asked us specifically to use the principle of conservation of energy in your answer, and according to the principle of conservation of energy, energy is neither created nor destroyed, one form converts into another. So we specifically mentioned that the gravitational potential energy store converts into kinetic energy store. Okay, so yeah. When the comet is away from sun, it has more gravitational potential energy and less kinetic energy. As it moves closer to the sun, the gravitational potential energy store converts into kinetic energy store. So as comet has more kinetic energy, hence more speed. Okay. So this brings us to the end of the paper. I hope you had a better understanding of the questions than you had before. Yeah, best of luck for your studies. Allah Hafiz.